This is a Lego part. Costs about 10 cents. If you're a parent like me, you've probably stood on one barefoot at some point. It took me 5 features to model it in SolidWorks, including one decision I want to talk about, because it's the kind of decision that separates people who genuinely understand SolidWorks from people who are just clicking through the menus. When you look at the bottom of this part, the obvious approach is shell. Follow it out in one hit. And that's actually what I did, but here's the catch. Shell removes more material than you want because there's a solid wall through part of the body that needs to stay. So you shell it, then you extrude back in to fill that section. That's not a complicated sequence, but the thinking behind it, recognizing what the tool is doing, understanding why it's creating a problem, and patching it with a second operation, that's real-world SolidWorks problem solving in a 10-cent plastic brick. And that's not a one-off. Every single Lego part has something like this hiding inside it, which is why after 50 lessons and over 140 modeled parts, I'm more convinced than ever that Lego is one of the best practice materials available for learning SolidWorks. In this video, I'm going to make that case and show you exactly which skills you'd cover and where to start based on where you are right now. So why Lego? Let me give you 3 reasons that I think actually matter. First, you can hold it in your hand. This is bigger than it sounds. When you're learning to model something, being able to rotate the physical object, look at it from underneath, measure it with calipers, that connection between the physical thing and the digital model makes abstract concepts concrete in a way that random exercise just can't. You know what correct looks like because you can compare it directly. Lego parts are manufactured to tight tolerances. The stud diameter, the wall thickness, the pitch, these are genuine engineering dimensions. When you model a part correctly, it fits with every other Lego part you've ever modeled. If your dimensions are wrong, you'll know immediately when you drop it into an assembly. That's instant feedback, which is exactly what you want when you're loading. Third, and this is the one that surprised me most, every part has a unique modeling challenge inside it. A basic 2x2 plate looks trivially simple, but introduces you to symmetry, origins, and why where you place the sketch matters. The curved slope I just showed you. Shell decisions and extrude patching. The tire. Revolve for the cross-section profile. Circular pattern with 32 instances for the tread. How do you know it's 32? You count them on the physical part. That's reverse engineering. And that's what product designers do every day. A gear introduces sketch contours, selecting only the regions of a sketch you actually want to extrude, rather than the whole profile. That trips people up constantly. A steering wheel introduces thin features for the spokes, a single line that gets extruded with a defined thickness, rather than a closed profile. There is no such thing as a boring Lego part if you're paying attention. And on top of all that, you can walk into a toy shop in any country and buy a Lego set. The barrier to entry is basically zero, which means the only thing standing between you and a structured, progressive practice library is about $20. I was convinced enough that I've live streamed the modeling, edited and split every session into individual lessons and catalogued the whole thing into a CAD library. Over 50 lessons, 140 parts, with plans for more. So what does the library actually cover? Let me give you a few examples because I think they tell the story better than a list would. The tire from the Off-Road Buggy. Most people look at a tire and think Revolve, done. But the feature tree on this part has a cut revolve, a surface cut, body operations, second revolve, and a circular pattern on top of that. It's the most complex part in the entire project, and it's a tire. The worm gear from the Volvo wheel loader. That thread geometry isn't extruded, it's swept along a helix. Helix and sweeper features most beginners haven't touched. And here they are in a part you could buy for 50 cents on Bricklink. And the chain from the motorcycle. That one uses a belt feature and a chain pattern, tools that feel firmly in professional territory. Most SolidWorks users go years without needing them. They're in here because the model demands them, not because I went looking for complexity. Those 3 parts or features alone cover a range that most SolidWorks courses would spread across multiple modules. And they're sitting inside sets you can buy at a toy shop. The full picture, shell, mirror, sketch contours, cam mates, exploded views, and more is spread across 50 plus lessons in total. But you don't need to know all of that to get started, which brings me to where you should begin. So if you're convinced, or at least curious, here's how to find your way in. If you're a beginner, start with the Off-Road Buggy. Lesson 1 is a flat 2x2 plate. By lesson 5, you're using shell and pattern features on a full brick. The ramp is gentle, but the skills are real. By the end of the series, you'll have a complete assembly and a solid foundation in the features that come up most often. If you want to push your part modelling, the Volvo wheel loader has the most interesting geometry of the 3 series. The worm gear, the hinge cylinder with its draft feature, the curved side panel, the digger bucket. If you want the parts that make you think the hardest, start there. If you want serious assembly work, the motorcycle is where the assembly skills get real. Cam mates, width mates, in-context design, chain component patterns. It's a more advanced project, and the techniques it covers translate directly to professional work. And if you want everything in one place, the parts, the assembly files, and the video lessons all live inside my school community as the fully defined LEGO CAD library. It's free to join, and it gives you access to over 140 modelled LEGO parts with links to the relevant tutorial videos. That link is in the description. Most people learn SolidWorks on abstract exercises that feel like homework. Features without context, geometry that doesn't mean anything. LEGO isn't that. The design intent questions are real. The decisions matter, and when you're done, you have a part that either fits or it doesn't, which is exactly the kind of feedback that makes you better. Everything's linked below. I'll see you in the next video.